Good morning. Welcome to week 8 in forensic ballistics. Today we are going to discuss the steps in the manufacture of firearm barrels and enumerate the two general characteristics to be considered regarding ballistic examination. So let us have first arms manufacturing processes related to the firearms identification. It is very important that a ballistic expert or firearms examiner be sufficiently familiar with the various steps in the manufacture of firearm in order that he will be able to explain the source or cause of the different markings which may be found on a firearm evidence and may be a basis of his identification. There should always be a sound reason for all markings, scratches, or dents visible on firearms evidence, and it is the function of the firearm examiner to determine how and why they are made, and also to interpret their significance both to himself and to the court. Most of these markings are transferred in the firearm evidence by deliberate or accidental operations of the tools during the process of manufacture. So let us have the steps in the manufacture of firearm barrels. Step 1, this is drilling the hole. This operation results in drilling deep, accurate drop holes longitudinally uniform in diameter from one end of the barrel to the other. Second, we have reaming the hole. This operation removes some of the scars and scratches left by the drilling operation. The hole is reamed carefully to the exact bore diameter. Third, we have cutting or putting the rifling. Firearm barrels have grooves cut or pressed in the bore, which produces rifling. These grooves are cut in spiral pattern. Between the grooves are raised areas. These are called lands. In firearm examiner lingo or language, rifling refers to the lands and grooves. The lands are the raised portion between two grooves, while the grooves are the depressed portion. The rifling methods are the following. Brooch rifling, a tool having a series of cutting edges of slightly increasing height used to cut the spiral grooves in a barrel. All grooves are cut with a single pass of the brooch. Bottom rifling, a hardened metal plug with a rifle cross-section configuration. It is forced or pulled through a drilled and rimmed barrel so as to hold from the spiral grooves to the desired depth and twist. Then we have hammer forging, an internal mandrel with rifling in the barrel by means of external hammering. Then we have the hook cutter, a cutting tool which has a hook shape and only cuts one groove at a time. Scrape, a cutting tool which cuts two opposing grooves at a time. Lapping, it follows after the rifling operation is completed. This is the smothering of the inner surface of the gun barrel, polishing the inside of the barrel like a mirror with a polishing compound. Chambering, the final step is the chambering or cutting away the breech end of the barrel for the cartridge or shotgun shell is 2 feet. We have here the types of rifling. Cut rifling, made by a Booth's cutter or button, which produces rifling with sharp edges. Bore refers to the cylindrical passage of a barrel through which the bullets travels. Polygonal rifling, lands and grooves having a rounded profile. This type of rifling is produced with hammer forging. Now let us have the two general characteristics to be considered regarding ballistic examination. First is the class characteristics. Intentional or design characteristics that would be common to a particular group or family items. The characteristics that is determinable even prior to the manufacture of the firearms. These class characteristics are factory specifications and within the control of man. Class characteristics serve as the basis for identifying a certain group or class of firearms. The following are class characteristics of firearms that can be determined in fired bullets. We have the bore diameter and the rifling pattern contained in the barrel of the firearm. Rifling pattern contained in the barrel of the firearm consists of the following items. We have the number of lands and grooves, width of lands and grooves, depth of grooves, direction of twist, rifling either twist to the right or to the left, pitch of rifling, this is also called degree of rifling twist. It simply refers to the distance, which is measured either in inches or centimeters traveled by the lands and grooves to complete a single rotation, which is 360 degrees. All class characteristics are measurable in caliber, number of lands and grooves, width of lands and grooves, direction of twist, depth of grooves, and pitch of rifling. The second characteristics to be considered regarding ballistic examination is the individual characteristics. This is also called accidental characteristics. When a firearm is manufactured, the individual parts are made with tools that are in a constant state of change. As a result, no two guns will leave the same marks on the ammunition components. Separate a single item from a large item. Consider fingerprints in that they are unique to that item. Sources of individual characteristics of firearms. We have the wear and tear of the tools used in the manufacture of the firearm, the action of oxidation, the care of the firearm by the holder, the use of the firearm by the holder. Marks found on fired bullets. A bullet is slightly larger in diameter than the bore diameter of the barrel in which it is designed to be fired. As a result, a rifled barrel will impress a negative impression of itself on the sides of the bullet. Impress tool mark features produced when a tool contacts an object with enough compressive force that it leaves an impression. Then we have striated tool marks. Features produced when a tool contacts an object with a lateral force and motion. So under illustrated tool mark, we have landmarks, the depressed portion found on fired bullet caused by the land. Then we have groove marks. This is the raised or elevated portion caused by the grooves. Land and groove marks together are called rifling marks. These are striations found on the periphery, bearing or cylindrical surface of the fired bullets. Rifling is a series of helical grooves in the interior of the barrel, which causes the bullet to spin and make it more stable, like a spiral on the football. Skid marks, this happens when the bullet enters the rifle bore from a stationary position and is forced abruptly into the rifling. Its natural tendency is to go straight forward before entering the regular rifling twist. These markings are more pronounced in the revolver in force due to worn-out barrels. Slippage stripping marks, these are marks found on bullets fired from a worn-out barrel and on barrels. Shaving marks, most commonly found on bullets fired from a revolver due to a poor alignment of the cylinder. We have the marks found on fired cartridge case, firing pin impression, the indentation in the primer of the center fire cartridge case caused when it is struck by the firing pin. Breech face markings, negative impression of the breech face of the firearm found generally on the base or the head of the cartridge case after firing. Then chamber marks, marks upon a cartridge case by the chamber wall as a result of any or all of the following: the chambering, expanding during firing, and extraction. Extraction marks are marks produced upon cartridge case from contact with the extractor. And then these chamber marks are usually found on or just ahead of the rim. These are also usually found on shells fired from pistols, rifles, shotguns, and machine guns. Ejector marks, still we are under marks found on fired cartridge case. Ejector marks, a part of the firearm that is designed to expel the cartridge case from the action of the firearm. Shear marks or the secondary firing pin marks found in the primary near the firing pin mark. And then firing pin drag marks, which is caused by the protruding nose of the firing pin. Other marks found on fired shells are the pivotal marks, magazine lip marks, and the breech closure or anvil marks. This ends our discussion. For your activities. For your activity 1, I gave you illustration. So please refer to the suggested reading event so that you will have the basis of your illustration. And then we have the multiple choices. Again, I will advise you to please always apply the elimination process for you to come up with the correct answer. Thank you and good day.